Okay, it is 2 minutes after 8. It looks like the number of participants is slowed down joining up. So I'd like to welcome all of you, ladies and gentlemen, to Fly Fishers International Online Season 2. This is the second year of these webinars that we've been bringing to our members and community. Especially during the winters, and their general purpose is to share with all of you information on various aspects of fly fishing that we hope you'll find interesting, but more importantly, we'll hope there will be something in these webinars that will enhance your enjoyment of fly fishing in general. I'm Tom Logan. I'm chairman of the board conservation committee. The general topic tonight is conservation. This will be a conservation webinar that focuses on conservation of fishes and their habitats, natural areas in general. The specific topic tonight, which I'll introduce more formally a little later on, will be about the reintroduction of the Arctic Grayling in Michigan. But before I introduce our speaker tonight and the title of the presentation for tonight, I'd like to introduce a couple other individuals. Jake McLaughlin, who is on our staff in Livingston, Montana, is in the background and is going to be helping with any technical issues we may encounter, which we shouldn't have any problems there. The other individual I would like to introduce is Dave Peterson, who is chairman of our board of directors of Fly Fishers International. Dave will be helping me tonight by monitoring the questions you may type in using the Q&A tab at the bottom of your screen. We'll not be using chat, so use Q&A to type in your questions, and we'll get to your questions after our presenter has completed her presentation for tonight. These webinars, I hope you understand, are only made possible with the support of our members through their memberships that they maintain. So it's very important that you as a member continue to support the organization. The webinar tonight, as is all of them, will be recorded, and they can be viewed by anyone who wants to visit our website. And I'll give you a little more information later tonight on just how to access the recordings of all of our webinars. As I said, the topic tonight is about Arctic Grayling. The specific title of the presentation tonight is Arctic Grayling Historic Distribution, Research, and Restoration in Michigan. The three authors of the presentation are Nicole Watson and Drs. Daniel Hayes and Troy Zorn. Nicole, who will be presenting the program tonight, is pursuing her doctorate at the Michigan State University in the Department of Fisheries and Wildlife. What she will be talking to you about tonight regarding reintroduction of grayling in Michigan generally is the subject of her doctoral research. So this will be very interesting. Nicole is an avid fly fisher. She is passionate about wild salmonids, so obviously she enjoys fishing in her home waters of northern Michigan for brook trout, but as it wouldn't surprise you, given the topic of tonight, she also enjoys fly fishing for grayling in the interior streams of Alaska. So with that, I'd like to introduce Nicole. Nicole, it's my distinct pleasure to host you tonight and have you on the webinar with your presentation. So thank you very much. And with that, I turn the floor over to you, Nicole. Thank you.
Thank you, Tom. It's a pleasure to be here this evening. Let me go ahead and share my screen here, and we'll get started. All right. So, like we already said, the topic is Arctic Grayling. And definitely would like to acknowledge my two co-authors, Dr. Daniel Hayes and Dr. Troy Zorn, both on my doctoral committee at Michigan State University. In addition, my committee members also include Drs. Jeanette Bauman and Dr. Michael Wagner. I would also like to acknowledge the primary funding provider for this research. I'm sorry, let me adjust my video here. Okay, there we go. So the primary funding provider for this research is the Charles Wilson and also the Henry E. and Consuelo S. Wenger Foundation. Without their funding, this research would not be possible. I would also like to thank my primary laboratory technicians, Tim Hawley, Mark Hamlin, Josh Delanoy, Bailey Lorenzen, Robinson Gingrich, and Shayna Altus. And also I had a slew of volunteers that helped out throughout the project as well as additional funding help from societies and groups that you can see across the bottom here: Ironfish Distillery, multiple trout and limited chapters, St. Joe River Valley Fly Fishers, Michigan Fly Fishing Club, the College of Ag and Natural Resources for a scholarship, the Shrems West Michigan TU scholarship, Red Cedar Fly Fishers received their scholarship as well. Great Lakes Council of FFI, thank you for their funding and their scholarship as well. Assalville River Property Owners Association, and special thanks to Fly Fishers International. I was a recipient of the Conservation Scholarship in 2019, in addition to Emily Dean, and actually found out that I had received the scholarship on the day I was transporting eggs from Fairbanks, Alaska, back to my lab in 2019. So it was a very exciting day that it just so happened. So moving on, I'm sure a lot of you in this presentation are at least knowledgeable of what a grayling is, but in case you haven't seen one in person, I just want to touch a little bit of the history of grayling. So they are a member of the salmon and trout family, Salmonidae. They are a cool and cold water species, and they do have a very variable body color. They're individually unique patterns of black spots on their sides as well. So if you see in these photographs here, this gives you an idea of the distribution of body coloration. These are not different species of grayling that you see across the bottom. They are all the same species. They're Arctic grayling. They were all caught in the interior of Alaska. And you can see that the coloration varies from silver that you see on the left to a bluish purple in the middle to gold. And they can also have any color in between. So a tealish green coloration, a pinkish mauve hue. It is highly variable. And you can see a little on the one on the right, those black flecks on the body. Those are a unique pattern that each grayling has. Some will have very few spots, some will have more. So they have this sail-like dorsal fin, and the color patterning is also unique to the individuals. Males have a larger dorsal fin than the females. So if we look at the grayling photographs here, so all of these were grayling that I caught in Alaska, same with the previous slide. The one on the left is a male grayling. The one in the center is a female, and the one on the right is another male. And one of the ways that you can distinguish on an adult grayling if it's a male or a female is if you gently fold back the dorsal fin, or if it just naturally folds back and it either reaches the adipose fin or goes past it, it's most likely a male. The males are typically more colorful, especially in the spring during spawning season. And the females, like the one that you see in the center, the forward portion of the dorsal fin is going to be slightly taller than the males. The males is more elongate towards the back. The female's dorsal fin does not quite reach the adipose fin if it's folded down. I do definitely want to stress though, that if you do ever catch grayling, please do not hold the dorsal fin up for a display. And also do not press it down. It can cause injury to the fish. So that's something that you really want to focus on is your care and handling of these fish, since a lot of us do enjoy fly fishing. We want to make sure that those fish are uninjured after we catch them. If we're looking at the world distribution of grayling, there are 6 recognized species of grayling that are found globally. And you can see the map on the right gives you a identification of their coverage. So the Arctic grayling is found in North America, Asia, and has limited distribution to the Eastern European tributaries. European grayling obviously is found in Europe. Amur grayling is in Russia, China, and Mongolia. Habsgold grayling is in Mongolia, and it's only found in 1 lake. Baikal grayling is found in waters of Asia. The Mongolian grayling is found in Russia and Great Lakes Basin in Mongolia. When we focus on North America, though, it's found in northern Canada and Alaska, and there's 2 primary glacial relic populations. One has been extirpated, the one in Michigan. The other is extant, and that is in Montana. And you can see that here in the map on the right. So the purple is the coloration that they are currently found in. That pink coloration is where they have been introduced in non-native areas, and the gray that you see overlying Michigan is where they were found historically. I do want to go over a little bit of their life history. So grayling are spring spawners. They're also idioparous, which means that they can spawn several times over their entire lifespan. The eggs are very small, so they're about 2.5 millimeters in diameter. And these fish mature typically within 3 or 4 years. Their lifespan varies based on where they're found. The average overall is 18 years for an Arctic grayling. However, they live longer in Alaska. The water's colder, so northern Canada, more of those cold Arctic waters, the fish tend to live longer and they grow slower. The oldest fish caught to date is 32 years old, and that was caught in Alaska. Montana, the average lifespan is about 5 years. In Michigan, we're estimating that their lifespan would range anywhere from 5 to 10 years. And that is also consistent with what was historically seen. So if we look at the past of grayling, this is focusing on Michigan. Here are 2 photographs that kind of give you an idea here. So Michigan grayling, the photo on the left, were indeed Arctic grayling. And these fish were taken from the Black River in 1903. And you can see that it was widely advertised to come to Michigan for fishing specifically. And it was advertised through the railroad system, which was referred to as the fishing line. Their distribution in Michigan, overall, they were first discovered in the mid-1800s. And their primary distribution was the northern lower peninsula. So if you look at your hand, anything north of the knuckles, there's really nice cold trout water. It was all inhabited by grayling. The upper peninsula, however, was brook trout water. So the distribution of fish that we had in Michigan is, if you look at those blue colorations here on the map, these were all grayling waters. And you can see one in the upper peninsula. This is the Otter River. And it's unclear if this was a naturally occurring glacial relic population or if the fish were transported there from early European settlers. There's also a game ranch and fishing club that was right around the Keweenaw Peninsula. So it's not unlikely that they may have been simply transported there and introduced to the Otter River. The distribution, though, like I said, the brook trout primarily inhabited the upper peninsula. The lower peninsula was grayling. There were some brook trout in these northern peripheral lake waters, but that's really, they were distributed northern and lower, upper and lower that way. They were a widely fished fishery. So Grand Rapids and Indiana Railroad had the fishing line, and this advertised early recreational fisheries in Michigan. So this is a historic map that you see here on the right. And one of the downsides, though, is there was no fishing regulations. So people could come in and fish as many fish as they wanted. They could keep them. So overfishing ended up being rampant in the area, which caused problems. So this started to lead to the decline and extirpation of the original grayling in Michigan. Declines were noted in the late 1800s, and there's 3 primary factors. Overfishing was the primary cause of decline. It's not unheard of that people would go and catch fish, pile them up on the bank behind them, and the pile could reach shoulder height. They would select a few fish, leave the rest to rot on the bank. Logging camps would be fed through grayling. There was also an industry for grayling where grayling would be caught and shipped down to restaurants in Chicago, Detroit, New York areas by railroad boxcar loads. Another factor leading to their extirpation was logging. Logging was very detrimental to the watersheds. You can see here, this is clear-cut logging that was done in the late 1800s, early 1900s. So not only was there clear-cut habit or practice for the forest, they would then slough the logs down the bank and float them down. You float logs likely in the spring when the water is the highest. And remember, when we talked about just a few minutes ago, grayling life history, grayling are spring spawners. They have a very short incubation period as well. So these fish mature to hatch in approximately 20 to 23 days. So the logging and floating the logs down is scouring the bottom of the watershed. It's ruining habitat. It is covering eggs with sediment. It can suffocate adult fish and juveniles. So it really does a lot of harm to the watershed and to the fish themselves. Then on top of that, so you had overfishing, logging, and then you add on competition. So other fish were starting to be introduced to the watersheds as the grayling were already in a decline. So you had the introduction of brown trout from Europe, and you had culture and introduction and expansion of range of brook trout as well. Other Pacific salmonids were introduced, and this all led to extirpation of grayling. There were previous reintroduction attempts. So the official extirpation for grayling was approximately 1936, and the last one was caught in the Otter River. So in that time frame, though, from about 1880, when they started noticing declines, there were attempts to expand the range of grayling through restoration and reintroduction attempts. And when you look at historic records, the range expansion even included areas in southern Michigan, such as the St. Joseph River. None of those took. In the early 1900s, so 1900 to 1933, there were over 3 million fry stocked. So they were hatchery reared, stocked into the rivers. From 34 to 41, 70,000 yearling were stocked. 58 to 60, 300,000 fry were stocked. And the most recent attempt was from 87 to 91, in which yearlings were stocked in 13 lakes and 7 streams. So we'll touch on a little bit of what's going on now. So the images, I'll walk you through them here. This is how you transport fish eggs from Fairbanks, Alaska, back to Land, Michigan. So in the upper left, you see eyed grayling eggs, and they're laying in cheesecloth. What you see on the right is we are wrapping those eggs. So that is 10,000 Arctic grayling eggs that we are wrapping gently with cheesecloth. And then in the center left, that is the cheesecloth burrito of grayling eggs. And down on that lower portion is a grayling from 2019 after it was about 5 months old. So there's a current initiative going on in Michigan. It's called the Michigan Arctic Grayling Initiative. And the overall goal is to restore self-sustaining populations of Arctic grayling within their historical range in Michigan. It was established in 2016, and there are currently over 50 partners all involved in this restoration. You can keep track of it and get more information if you go to migrayling.org, and you'll have to excuse my setter puppy who's suddenly wanting attention. There are some key concerns that come about with this reintroduction, though. So we now have the presence of non-native species. This can lead to competition and predation. Previously, there was rapid outmigration, and we're unsure if that was from a lack of imprinting to the stream, or if it was because the fish were raised in a hatchery type system and then introduced to unfamiliar waters. So think of it as if you're taken from your hometown and you are transported to a completely different country and you have no idea where you are. You will try to find your way back home. So could the rapid outmigration have been simply because they were trying to find that familiar scented water? Also, habitat requirements. It's been confirmed that habitat is still available in the Lower Peninsula of Michigan in their historic waters, but we may need to address some issues with connectivity. So there's impoundments that have been put up in the meantime. And then also you must address the potential impacts of climate change. So the water temperatures have elevated. So we need to keep that in mind, that there could be some changes overall. So one of the key questions that I often get is, I showed you all these previous attempts to reintroduce grayling in Michigan and told you that they all failed, right? So why try again? It hasn't failed in the past. Why are we expecting something different? And this right here is the key. So Montana started seeing declines in their grayling population. And they were having some issues when they were trying to restore. So fortunately, their grayling were not extirpated, and they simply could look to restore the population. They started noticing that fish that they would raise in a hatchery and reintroduce to the streams would outmigrate pretty quickly. So the same issue that Michigan was having all along. And what they started using is what's called a remote site incubator. And this remote site incubator led to developing site fidelity in their grayling that were reintroduced to the streams. So they didn't rapidly outmigrate. And we'll go through how it works. So here's a schematic on the left and an example on the right. The example on the right is using steelhead eggs. They're much larger than grayling eggs. It's just so you can see it overall here. What it basically does is you have an inflow pipe here, which is plumbed into the stream that you want to introduce the grayling to. So that water then that they're going to be introduced to flows in, aerates through the system, and there's an egg tray, and you actually placed eyed eggs on that egg tray. So they are constantly being bathed with the water at which you're wanting them to live in, establish a population in. And there's an outflow pipe, and you can see this in the image here. The outflow pipe's at the top, and you put a mesh over it to where the eggs don't get washed out. When the eggs hatch, the alvin will stay in the sediment. They'll stay within the substrate on the egg tray until they're ready to swim up and go into the stream. Then they just swim out the outflow and establish the population right in the stream. The key is that they have been experiencing that home water that you want to introduce them to the whole time. So the use of this RSI really led to Michigan having the initiative to reintroduce grayling once again. So I have three primary research goals here at my MSU research. It's just part of the overall reintroduction effort. So for me, I would like to determine the timing of imprinting in grayling early life history. I'm also aiming to determine predation rates on grayling fry by age 1 Brook and Brown trout. And I would also like to determine the impacts of competition between Brook and Brown trout of the same age class. So all age 0, they're all approximately 4 to 5 months old at the time that I do the competition trials. So getting grayling back to Michigan is quite interesting, I guess you could say. You're at the whim of weather and patterns with ice out, it's called. So as the ice starts breaking up in the waters in Alaska, that's when the adult grayling are going to start their spawning run. So they'll start traveling from, they'll start traveling from their overwintering habitat. That ice starts breaking up and they'll start traveling to their spawning ground. So it all depends on the weather patterns throughout the entire winter, how thick the ice has been, so it can vary. 2018, The egg take, which was when the adults were ready to spawn, occurred on May 15th. In 2019, there was a very early ice out, and the egg take occurred on May 6th. I arrived in Fairbanks on the 30th of May in 2018, but the 10th of May in 2019, departed Fairbanks June 4th in 2018, May 20th in 2019, and you can see the hatch dates here. So overall, from the time that the eggs were collected until they hatched, it can be 21 to 23 days based on these 2 years here. So you can see the flight pattern here. We collected the eggs from Fairbanks Hatchery and transport them all the way back to East Lansing. So this is our research laboratory here at Michigan State University. It has been modified slightly, but this is the overall pattern. I have 3 artificial streams that are set up in my research lab. I also have an incubation area, which is not really easy to see in this image. It's in the center here. We have a completely recirculating system with a UV sterilizer, sand filtration, and 2 single horsepower chillers. On the left here, you can see the eyed eggs once they've been in East Lansing for a bit. And you can see a few have already hatched in this image. So up towards the center here, there's a few, these are called Alvin. And you can see their small yolk sacs here. So if anyone's been helping with trout in the classroom, or if you've ever seen very young salmonids, you would notice that the yolk sac on these grayling are very small compared to a brook trout, brown trout, or other Pacific salmonid. We incubate all of our own food when they're a fry. So we do a daily rotation of food. Food is grown every single day. And here is some of the holding chambers for the grayling. And these were about 3 months old. So when we look at imprinting, overall, we're trying to determine when very young grayling are actively imprinting. So when I say very young, I'm talking as early as the eyed egg stage. So we also look at various times at which they're going through an ontogenetic shift. So a dramatic change. So from going from eyed egg to hatching, from hatching to an alvin, alvin to swim up, and then subsequently through there. So I use T4, so it's hormone thyroxine. And you can look at the content of it in the fish, and based on different concentrations, it can lead you to determine a time frame at which that fish could be imprinting. We can also use water choice trials to determine if these young fish are recognizing familiar water or not. And that's where we're going to address if rapid outmigration in the past could have simply been due to unfamiliar water or a lack of imprinting. So if it was due to a lack of imprinting, you would expect that grayling are imprinting to their home waters very early. So before they would have been introduced from a hatchery to a watershed, which is why those RSIs are likely working. And then rapid outmigration to unfamiliar water, you would expect to see this image here is a water choice trough. And it's, so there's 2 choice channels here, and you can you place a fish in a choice arena. So that's going to be over towards the left center. And you do 2 water sources, and the fish can choose which arm of this choice trough to go into. And you would expect to see them drawn to a familiar water or avoid an unfamiliar water. So if we go on to predation, so why are we so concerned about predation? And it's primarily because younger age classes of resident trout are often in higher densities in these little headwater streams and smaller systems that would be ideal for introducing young fish. So it's important to understand the impacts of predation on very young grayling. And I focus on predation rates of brook and brown trout and also the behavior of the grayling fry. So these trials start when the grayling fry are approximately two weeks old and go through until they're about 2 months old. So these images are to size scale here to give you an idea of the size comparison from the age 1 brook trout to the fry and an age 1 brown trout there. And if we look at some preliminary results, so this data is from 2018 and 2019 trials that were done. We're looking at the grayling consumed per hour overall based on grayling fry age class. And the images that you see across the bottom give you an idea of what that grayling fry age class actually looks like developmentally at that time. And you can see that about 2 weeks old, they're very small, they're underdeveloped, their fins are very poorly developed, their musculature is very poor. And when you get to about fry age class 2, you see some further development of that dorsal fin, but their pectoral and pelvic fins are still pretty undeveloped, and so is their caudal fin. When we look at fry age class 3, they're actually starting to look more like a fish. The dorsal fin is much more developed, the caudal fin looks very well developed, and their pectoral and pelvic fins are actually forming quite well, plus they're also getting a very nice musculature at this point. And overall, what we found is if you look at the rates of predation, so grayling consumed per hour, based on brook and brown trout, so brook trout are the solid blue line and brown trout are the green dashed line, you can see that for both species, the number of grayling fry consumed per hour declines as development increases of these graylings. So the older the grayling get, the less they're preyed upon. Brown trout do prey upon grayling at a slightly higher rate than brook trout, but it was not statistically significant at this point. So if we transition to competition, again, addressing the why do we care? So competition between age 0 resident trout could adversely affect grayling survival. And there's 2 potential reasons. So it could be because of possible size advantage. It could be due to differences in behavior, but especially that potential for a size advantage from brook and brown trout being larger than grayling. It can lead to some aggressive interactions between the species. So when I showed you those images of grayling earlier on, it's important to understand that grayling hatch out in the spring, and when they hatch, they're anywhere from 7 to 11 millimeters in size. When they come up from the substrate, it's only about 3 to 5 days after hatching. They need to get on food right away. They're about 11 to 15 millimeters in total length, so very small. Brook and brown trout have a much larger yolk sac. They stay in the substrate much longer. They start to mature a little and develop better. When they come up from the substrate, they're anywhere from 25 to 29 millimeters in total length. So they're about double the size of a grayling early in life. So through these competition trials, I focus on changes in growth, behavioral interactions, and also habitat use. And this image that you see here on the right is one of the artificial streams. So there's 3 of these artificial streams. Each one is identical to the other. If you look at the image here, the inflow water is up at the top. The water flows down. It's a sinuous type of stream, so there is some bending in the movement of the water. There's a couple point bars. These black little pieces you see are to represent an undercut bank. There's some areas that the fish can hide, some woody structure, some artificial plants, and then a pool down towards the bottom. And if we look at some preliminary results for competition, so this is again data from 2018 and 2019. The competition trials are a total of 2 months long, and I weigh the fish every 2 weeks. So I weigh the brook trout, brown trout, and all the grayling from each stream. So if we look, again, the brook trout, this is looking at grayling weights in the brook trout treatment. So this would be the mean weights for 10 grayling that were in an artificial stream with 10 brook trout. If we look at the brown trout treatment, so that's the green dotted line, that is the average weight of 10 grayling in the presence of 10 brown trout. And the control is that red dotted line, and that is the mean weights for 20 grayling. So multiply that by 2 for both years. And what you can see overall is the growth trend in both the control, the red dotted line, and the blue solid line shows positive growth over time. So that is indicative that the grayling, whether they're just among grayling or if they're in the presence of brook trout, do show positive growth over those 2 months. It's a different story if they're in the presence of brown trout. In the presence of brown trout, you do not see that positive growth, and you actually have a higher degree of mortality in those fish. So to summarize it, when we look at those predation trials, again, brook and brown trout both prey upon grayling. Brown trout do have a slightly higher predation rate overall, but the rate of predation decreases as grayling growth and development increases. With competition, brook trout do not appear to affect grayling growth or survival. In the 2 years of trial, our mortality rate was 10% for overall in the brook trout treatments. So the first year in 2018, all of the graylings survived. They all showed positive growth. In 2019, 2 grayling died in the trials, and all the rest showed positive growth. Now, when it comes to brown trout definitely have a negative effect on the growth of grayling and their survival as well. So overall, the first year of trials, so 2018, we had 60% mortality by the end of the trial. So 60% of the grayling, 6 out of 10 died. In 2019, we repeated the trial the same way, 10 grayling, 10 brown trout. And by week 6, all of the grayling had died. So we had 100% mortality of the grayling in 2019 in the presence of brown trout, and only 1 brown trout died in the trial on either year. So 0 mortality of the brown trout in 2018, 10% mortality of brown trout in 2019. When it came to the brook trout also showed positive growth even in the presence of grayling, and I had 0% mortality in the brook trout. So overall, the fact that brook trout do not appear to affect grayling growth or survival was very hopeful. And another thing to really consider is these competition trials that I perform in my stream systems. They're a closed system, so the fish cannot escape the impacts of competition. So there's no refuge that they can take in that stream, like another channel or a location that the grayling or the brown trout are not in. So overall, these results give us hope that the reintroduction of grayling to Michigan streams could be successful overall. So if we look at the future of grayling in Michigan, so in 2019, I reared the first year class of broodstock for the state of Michigan. On August 1st, 2019, 3,759 Arctic Grayling fry were transferred to Odin Fish Hatchery. Me and my technicians counted every single fish. There were 3,759, we're 100% sure. That's what happens when you have fisheries people doing stuff, right? We will count every single one. So you can see in these images here, this was a big day. This was the first year class of broodstock to be reintroduced as part of the reintroduction in Michigan. So they were transferred to Odin State Fish Hatchery. Odin Fish Hatchery had a UV sterilizer put in, and so they were able to hold these fish safely without the risk of disease being exposed to surrounding watersheds. Once the fish were certified disease-free, which takes approximately 18 months, they were transferred to Marquette Fish Hatchery, which has now just occurred late this fall. So just recently, the 2019 cohort of broodstock was transferred to Marquette Fish Hatchery. There, they'll continue to grow and mature. Next year, so COVID, of course, had plans for everyone that we did not foresee. So we do not have a 2020 cohort of broodstock, but 2021, I will be collecting the next cohort of broodstock fish with the help, of course, of Michigan DNR and Alaska Fish and Game. And we will then incubate my fish for my research in my lab, and then I'll transfer right away eggs to Odin Fish Hatchery for them to start another year class of broodstock. Once these fish have matured, we'll be able to get eggs and milk from them and start using the remote site incubators and start the reintroduction in the state of Michigan. So it's approximately 5 years out, depending on how long it takes for the fish to mature. So definitely would like to take some questions. I want to thank you again for the invite to present as part of this webinar series. This was actually the first grayling that I ever caught, and it was part of my research. This is from the interior of Alaska, within the watershed that Michigan's first year of broodstock was in. So definitely a very meaningful catch for me there. So with that, I will take any questions now, and we can do that through the chat.
Thank you, Nicole. Appreciate that very much. We're going to take our questions through Q&A, and Dave is monitoring those. I do have one question before I turn this over to Dave, and I think you touched on this. As the grayling matured, do they petition differently from brook trout or brown trout? Use habitat in the stream differently? There was something that you touched on that I missed there.
As far as them, I'm sorry, repeat that.
As the grayling matured, do they petition differently in the stream habitats from brown trout, for example?
They may. So grayling do like to travel quite a bit. So they really need a connected watershed. Within their first year of life, they're going to stay pretty much in that juvenile type waters. So where they would be reintroduced. As they mature, they're going to wander quite a bit more. It depends on the habitat suitability. There is definitely the potential for overlap in habitat. They could partition, but a lot of the partitioning will likely be due to influences of competition or predation, most likely. As long as the water temperatures, the flow, the substrate is suitable to grayling, they would likely explore it. But again, that partitioning could be impacted just simply by their presence of brown trout in the system.
Okay. Okay, thank you, Nicole. Dave, I believe you have a few questions.
Yeah, we've received several questions. The first question is from James Shanley, and it pertains to the RSIs, Nicole. What are the poke rings that you had displayed in the RSI?
Oh, let me bring that back up here. Hold on. Okay, so in the RSI, the rings that were there, this it basically can be any sort of biomedia. So it could be like the little bio balls that you can get at an aquarium store. It can be pea gravel. It's pretty much anything that will allow the water to diffuse more before it goes through that egg tray.
Okay, thanks. Got a question from one of our conservation chairs, Mike Brinkley. What is outmigration? Where do they go?
Historically, we don't know.
Oh.
That's the easy answer. But when we're talking about outmigration, so if say they started in the headwaters of the Sauble here, where you see my cursor, outmigration would be they just move from the area that you want them in into a different area. So outmigration is just basically if you put them at point A, they pretty much disappear and just swim to a different system.
Well, this begs another question, Nicole, and there may be no answer to it, but if they outmigrate, are they existing in that place that they went to, or are they extirpated there, or don't we know?
So historically, we didn't know. So the previous attempts to restore grayling, what commonly would occur is grayling would be reintroduced to a watershed. So they would be reared in a hatchery. Most of the hatcheries use a groundwater type source, and then they would be introduced into a stream at either like a fall fingerling size, so maybe like 4 or 5 inches, or yearling size, which maybe 6 or 7 inches. And so they would be put into that different water. You would put them in and then they were gone. And the assumption is that they would just swim and explore different areas. And so the likely occurrence was they were either preyed upon or swam around, didn't find suitable habitat, and just naturally died.
Thank you.
You know, Nicole, that while you were describing that during your presentation, that reminded me of many of our experiments in Florida on reestablishing and translocating listed birds. And we refer to site affinity, which is a form of imprinting on a particular site. And, you know, what didn't take long to figure out was the earlier in the development of the particular species that we desired to relocate so they would establish someplace else. The earlier in their development, whether it be through foster rearing, moving juveniles that were at least old enough to survive, but had not yet established a territory of their own and would soon be doing that, the more likely that the relocation was going to be successful. Translocating adults didn't work at all.
Yeah, and you know, that was similar with, you know, Michigan having the issues without migration, and then Montana was having the issue without migration when they were trying to restore their population. Once they started seeing success and establishment of site fidelity using the RSIs, you know, that was seen as a complete game changer and provided a lot of hope for the Michigan reintroduction. That's really what got it all started in Michigan again, was knowing that there was potential for successful reintroduction using RSIs.
Very good. Dave, you have some other questions, I believe.
Oh, we got quite a few here. Next question is, will the grayling at some point be considered to be as a fish to be taken and eaten from the streams, or just as a game fish to be caught and released?
It's hard to say right now. So it would depend on the overall survey of the numbers of fish. So the overall goal is to establish self-sustaining populations of grayling. Once we reach that threshold, then it would be likely that it could be reevaluated. I would expect that initially it would simply be catch and release only, but it would depend on, you know, the overall success of the reintroduction, if you would ever be able to keep one.
Thanks, Nicole. Another question from Peter Y. What water temperatures are optimal, stressful, or lethal for these fish?
Oh, I actually took that out. I usually have that in my presentations. So the interesting thing is I'm sorry, my dogs are acting up. For brook trout, the ideal temperature range is, so first of all, you have ideal temperature ranges for fish for growth. So within that range, they'll grow well. You have your upper limit, and then you have your lethal limit. Between the upper limit and the lethal limit, your fish will stress. It won't grow as well. Its metabolic needs will increase. So that's why there's the 70-degree pledge. The water temperature is 70 degrees. You recommend you don't trout fish, you go warm water fish. And it's because of the level of stress that goes through with the fish and its metabolic needs. They're unlikely to be able to recover as easily. So for brook trout, the lethal temperature, I believe, is like 78 degrees. The ideal temperature range, I believe, is, and don't quote me on the exact temperatures, I know I'm within the range, I don't have it in front of me right now, is from, so for brook trout, I believe it's like 50 to 61 is ideal temperature range. For grayling, the ideal temperature range is 49 degrees Fahrenheit as the lower limit of that optimal. The upper limit of optimal is, I believe, 60 or 61. It's the same as brook trout, but the lethal temperature for grayling is 85 degrees Fahrenheit.
Interesting.
Which, yeah, the first time I read that in a paper, it was cited. And so I went back through all the citations and found a few other studies that looked at lethal temperatures for grayling, and it's all within like 82 to 85 degrees Fahrenheit, regularly within that 85-degree range. So the most important thing to understand is, yes, they have a very wide range from upper optimal to lethal, but that fish is going to stress the warmer it gets. So it doesn't mean like you can put a grayling in 80-degree water and expect it to perform well. It won't. And it probably wouldn't be able to for long anyway. But I mean, it gives us some hope, especially with impacts of climate change.
Excellent.
Okay, Dave, we've got about 4 minutes left for questions.
Okay, well, let's see how we can get through Rick Williams' questions. Nicole, Rick is one of our senior conservation advisors. His first question is, your competition predation data suggests that grayling introductions might be best planned for streams without brown trout. Are such streams available?
They are. And I have fished some of them in Michigan, and I'm not going to disclose what streams they are because I really like fishing them. But what's very important to remember is my studies are in a closed system. The grayling cannot escape completely from brook or brown trout in either the predation trials or the competition trials. In a natural system, there could be little tributaries coming in that they can escape to, or a different niche in the habitat that they're able to go to. Maybe the brown trout are going to be in a deeper pool and the grayling are going to be in a shallow riffle. So it's really hard to say right now. But yes, definitely it seems like they're going to do best in the absence of brown trout, or at least low density of brown trout.
Hey, Rick's second question is, what are the long-term plans for hatchery-supported introductions? In the Pacific Northwest, there's increasing evidence that the lowered fitness of hatchery-produced salmonids. Do you see any issue with grayling? And if so, what are their plans to decrease hatchery input if natural spawning starts to occur?
Yeah, so that's one of the main reasons that we go to Alaska for fish. So initially we were going to use fish from Montana, but remember I said Montana needed to use their own population to restore what they have. So their genetics were not as diverse as the wild fish. In Alaska, in the interior, the fish have not been stocked upon. So they have a stocking program in Alaska, but the fish that they stock are only in closed systems, inland lakes that are going to freeze over the winter. So it's a put and take type of stocking system. In their rivers, they don't stock on a wild habitat or population. So the goal right now in establishing these self-sustaining populations is you get multiple cohorts of broodstock and you get those refreshed from the Alaskan population each time you need more fish. So we'll probably do at least 4 to 5 year classes of broodstock initially, and you cross year classes. So you might take a male from 2019 with a female from 2021 or vice versa. And those fish would be crossed in the spawning. So you know you're not crossing siblings. That would be used for a year. And then, you know, when we need to get more fish, you go back to Alaska again, get that wild genetic diversity and bring that in.
Thanks, Nicole.
Okay, Dave and Nicole, we'll wrap this up. I'm compelled to comment from my endangered species experiences again, where our efforts to use captive rearing under various circumstances and in most respects have proved to be dismal. So I would suspect you've got a leg up on success in your project and going back to Alaska for wild broodstock each year. I'd be surprised if that isn't a certainty in your ultimate results. But anyway, this is very interesting. I hope we stay in touch. I'd certainly be interested in us continuing to monitor what you are doing, and if you'll let us know how we can assist as you proceed, I think that would be great. So thank you again for tonight. Appreciate it very much. I'd also like to remind our attendees tonight of a couple things. One is this webinar is recorded, so you can go back if you're so inclined and watch this one and others again. Certainly watch others that you have not had the opportunity to watch live. Simply go to flyfishersinternational.org, and I believe the information you need is right there on our the lead page on our website. You can find it there somewhere. If you have difficulty finding them, send either Dave or myself an email. You should be able to find our emails, and we'll be glad to help you. The other thing is to remind you that these are only made possible with your support as members. So if you're a member tonight, certainly continue to renew your memberships. It's very important to us. If you have a friend that is a candidate member for the organization, certainly invite them to join or pay their dues for them, and tell them you'll expect them to pay their own dues the rest of their life. That's very important to what we do. We need their support. So do maintain your membership, continue to support FFI and what we do. And also, and through your support and what you do and what you enjoy, you'll leave a personal legacy for yourself, for fly fishing, for conservation, and we appreciate that very much. So Nicole, again, thank you very much. Dave, thank you for helping tonight. And I appreciate all the participants that joined us tonight very much.
Yep. And I put my email address in the chat if anyone wants to send me any questions. It's winter break, even though I'm still working on my research. I'll have a little more time because I won't have class. So feel free to email me any further questions.
Okay, thank you, Nicole. So everyone stay safe and Merry Christmas to all and good night. Appreciate it.
Thank you.
Thanks.